Welcome to Study Loop.
So in this problem for part A, we know the thickness of a vessel is given by D. So D represents the thickness of your vessel. Uh, we know speed is V. And again, we just writing what you do know, given the problem. So we understand when when placed when the vessel is placed in the magnetic field, there's a force that emanates from that position where the vessel is placed. And the force in the is represented by F, the force that emits from the electric field, FB. F sub B is equal to the charge Q times the speed V times the magnetic field B. This force, it causes the charge to move. Hence, when the charge moves, there is a creation of an excess charge at both upper and lower ends, which in turn creates an electric field. That's where we have F times E, F sub E is equal to the charge that is being created times the electric field. That's the force that creates the electric field. These charges are in equilibrium. So Q sub E, the charges, so during the state of rest, equilibrium. So QE is equal to the charge times the speed times the electric field, where we could solve for E. The electric field becomes VB. The potential difference between the upper end and the lower end, using this equation, you could find V is equal to ED. Again, D being the thickness and E being the electric field. And let's call this equation 1. Now, we're going to substitute equation 1 for the value of E. Substitute substitute for E, and we're going to rewrite E as epsilon, as the Greek value epsilon. So epsilon is, so this is how you write epsilon, and for V. So if you rewriting this, so we're gonna substitute E, which is VB. So epsilon becomes the potential difference V times the field times the thickness. So that's for your part A. Epsilon is equal to the potential difference times the magnetic field times the thickness. For part B, they want us, says if you expect the diameter, if you expect that the blood will be flowing, what is the strength of the magnetic field? So they're asking for the strength of the magnetic field, given that it produces a potential difference of 1 MV. So they give us the potential difference PV speed, given the symbol is V. And we're told the speed is 15 centimeters per second. Converting 15 centimeters per second to meters per second, we have 0.15 meters per second. We're given the thickness in this problem to be D diameter is equal to 5.0 millimeters. Converting that to meters, we have 5.0 times 10 to the negative 3 meters. To find the emotional electromotive force, EMV, EMF, I'm sorry. So EMF, electromotive force, V is equal to, yeah, we could calculate the magnetic field B. We're just simplifying. So dividing both sides, we have now just substituting 0. The speed is 0.15. Inserting that into your calculator, you have 1.33 Tesla. So magnetic field, the units for magnetic field is Tesla. So which is represented by T. For part C, we are told to show the volume of the rate R of the blood is equal to R is equal to pi epsilon D over 4B. We know epsilon is equal to VBD. Solving For V, we have epsilon over BD. Now, the rate of flow of the volume is given by the notation R. So R is the volume rate of flow, which is equal to the area times the speed. And now we could just substitute those values. So we know the area is pi. We know the area is pi e pi epsilon d over 4b, which is the rate. Speed is velocity. I'm trying to rewrite that by the notation v. So a times v. So the rate is a times v. So area, epsilon over bd, pi d squared over 4, which is our area, times epsilon over the field times the thickness. So R becomes pi times the thickness times epsilon over 4b. That's it.